game that introduced by Yoshihiro Handori. He's professor from University of Tokyo. He has delivered a course, a MOOC course called Welcome to Game Theory. So that is pretty much a common course. If you like it, you can probably take a look at that course. Right. So bidding game, right? So what does this game all about is you have to take only 8 cards. Like let me explain that. So a deck of cards, in case you don't know about playing cards, a deck of cards consists of 52 legal cards plus 2 jokers, or sometimes you get a 3 joker also. 2 jokers plus an extra joker. For this game, we only required 4 cards from a suit. Suit is like there are 4 different suits. One is hearts, spades, clubs, and diamonds. Right. So these are 4 different suits. And hearts and diamonds are red color, and clubs and spades are black color. Right. So those are different cards. And each suit is 13 in number, like 13 red cards of heart suits and 13 red cards of diamond suits. Totally it is 26, and 26 black cards, like 13 being spades and 13 being the clubs. For this example, let's take a look at hearts and spades only, right? So I just choose only hearts and spades. So this is how it is like. I choose king of hearts, this is king of hearts, and king of spades. Right? So this is one, and this is two set one and set two, right? So red card separately and black card separately. And ace of hearts, ace you can even call that as one also, like in case you're not very familiar with ace. Then ace of spades, right? And then two of hearts and two of spades, three of hearts and three of spades. So it's a two-player game, two-player simultaneous game. This is a very important thing. This is typically mimic the scenario of bidding. Like you can think of auction. Auction is not simultaneous. Like no two persons give at the same time. This is different. This is typically the the sealed tendering, when which they evaluate all the tenders at once. Remember, in an open tender, they have to quote for their tender, and they will be given, like it's just like an auction. They say this amount, a particular job, uh, how many of you are quoting, then they'll say I quote for this price, the other quotes a little higher and higher, and goes finally the final ultimate maximum, right? So that's an auction, that's not a simultaneous, but this is a simultaneous, where a closed tender, where the advertisements itself will say it's a closed tender. So you submit your document within the stipulated time to the office, and at a certain time they evaluate all the tender at once. They don't evaluate individually. They'll just open all the tenders, and then they'll just look into which one has the optimal price and quality, quotation, something like that, right? So this is a typically the simultaneous game, but it's only two-player. For simplicity, we have used this two-player game, right? The rules of the game is pretty important. Kindly pay attention to this. This is very important. The two-player has to pick a card from a set, right? So this is a set. This is a set. Like if you are playing red, I'll play black. So you take a card, and at that time, I also take a card, and we both display at the same time. So it's not a delay. By seeing your card, I will not display, or by seeing my card, you will not display. We will be displaying at the same time, right? So I'll just draw a card from my pack of four, and then I'll just display, and you also pick a display, right? Suppose I take if you played red, then if you take two, meanwhile I'll just choose any of this, and I without a delay I just you know present it to you, right? And then there is a rule, like it's called playoff. Like in case if you have taken my operation research course, we have about this in mathematical form. We called about playoff matrix and all, right? So remember, we talked about dominance property in my previous course, operation research. But this is pretty much, non-mathematical way of doing that, right? So rules of that is fine. So it's very simple. 4 cards each person. One with the red cards are called red player, and the one with the black cards are called black player. You can decide by a toss, or you can decide among yourself mutually who is going to take which card, which colored cards or something like that, right? Once that is done, the rules of the game is fairly same, fairly simple, right? So if both player chooses king, like I draw a king of spade and you draw a king of hearts, then the rule says that red color wins. So don't ask me, it's just a rule, right? So why red wins is, this is the logic. If I choose king and you also choose king, red player wins, right? So what happens if one of the player chooses king, the other chooses any other than that? Like I choose king of spade and you choose any of this ace 2 3, then black wins, right? So I repeat, I choose king, one of the player choose king, and the other player choose the numbered card or other than the king card, then the black player wins, right? And what happens if you choose king and I choose any of this number, I still win, because the rule says that if one of the player choice is king, the black player wins. Whoever is the black player, he wins, right? So if both takes king, red win, and if one of the players choose king, uh, black player wins. So this is a constraint. Remember that, if even if I choose king, you choose king, the red player wins. So the red player choice is restricted. That what happens if I don't choose king, he will lose, right? So black player wins. So he will draw king very carefully. Otherwise, the black player will win always. Like you see, no matter the king of any color, but the black player wins, right? So that's why it's a restriction. So otherwise, the black player only, the red player only uses king, right? Right. If two player chooses dissimilar cards, right? So if I take ace and if I choose two and you take ace, and it is the red player who wins. And if the if you choose two of hearts and I take three of spades, and still the red player wins. So it's a dissimilar cards other than the king, so king is not considered here. Any of these choices, a2 3 and a2 3, any of this, if we take a dissimilar cards, if you take two of hearts and I take three of spades, or if I take ace of spades and if you deliver three of hearts, and the red player wins. And if you choose similar cards like ace, ace, 2 2 3 3, black player wins, right? So this is the scenario, and one round means one display, right? So once you finish that, you collect the cards back and you shuffle it, and you can probably change the notation or change the card, or you can go for round two. Right, so 50 rounds are played. This is something called simulations. We generally take a huge number, right? So what does that signify is that red player strategy and black player strategy. So two competitors bidding for a project. So two competitors are bidding for a project, and these are the rules. Like we don't have to really worry about cost now, like the cost of bidding or something like that. So just we mimic the scenario in a card game, right? So if red player wins, means he wins the contract by his strategy of deploying king, which might be lesser in cost or good quality specifications or something like that, right? So understand the scenario. In fact, I have played for 50 times. Like I just show you, right? So which player will win most of the time? So can you guess which player will be the red player or the black player by these rules? Right? So you can really predict it, but the result will be very different. Like I'll just let you know what that means. Here it seems like a red player has an advantage that if they draw both king, uh, the red player wins, right? So this restrict the black players to use king. If they use king and if a red player use king, then he wins, right? And if dissimilar cards, that's more obvious. No, we don't know what the other person is drawing. So most of the time it's a dissimilar cards. So the red player wins. Other than that, like if one of that is king or similar cards are very difficult to get because it's just as equal to king. Like normally it will be random, right? So getting a similar card is very difficult or not probably high. So that case, black player wins. So this looks like an upset, no? Like one of these is king, the other is not king. What happens if the red player do not use his king at all, right? So, but then even it become other card. Then if black player puts king and he wins. But if a black player puts a king and the red player also displays a king, then it's the victory to the red player. So it's almost all the decisions are interrelated, right? So our victory is not only ours, it's also by the action of the others. That's why it is game theoretic perspective, right? It's not individual anymore, it's a game theoretic perspective. And can this game can be modeled to solve for an unified solution? Yeah, true, uh, they can model with mathematical formulas and something like that. That's basically the Nash equilibrium in a game theory. So we'll discuss that in Monday's class, but let me run through the outcome. Right, so this is the first trial or first round. I display king of spades, then you display ace of spades, and then the rule says that if any one of that is king, the black player wins. In the next round, we both display the same number card, even then the black player wins. And then this time it's a dissimilar card, the red player wins, and 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 dissimilar card, the red wins. And I display king, the black player wins. Which means that after this trial, I understand that I need to somehow, you know, draw my king, because this guy is always, displaying what is that? Not king card. So I just display, and when I do that, I won. Right. So I had an idea like, oh, this is fine. After seeing this, and this guy thought like, we'll put ace, and also I just put ace, and similar cards, the black player wins. And this is king. I understand from my experience that um, I just provide king. Then this guy puts dissimilar cards, and I just win. One of that is king, so black player wins. And after this guy thought like, okay, this guy is drawing a king and he wins most of the time. What happens if this guy draws a king and the red also draws a king? So you know that rule: if both draws the king, then red player wins. But unfortunately, I have drawn a different card, so this will become victory for black itself, like from there. So the rule says that one of that is king, so black player wins. And then we play a similar card, black wins, and one he draws king, then black player wins, and he might think that okay, so next time he will draw king. So but then I didn't draw king, so I just draw two spades and this win. And both are similar cards, black player wins, and dissimilar cards, red player wins, and similar cards, black player. And it goes on like we have tried till 50 iterations. I'll just upload this document. So I've just tried 50 times, and this is the result, right? So it seems like the red has advantage, but the black has the numerical advantage. In most cases, the black wins. Right. So even if you iterate it to even more, like 100 times, 2000 times, like in a Monte Carlo simulation, they do 10,000 trials and something like that. So if you do so, in most cases, black player wins. So we'll talk about why black player wins, maybe in the next lecture, and that is what we call a Nash equilibrium, right? So that comes to end of today's lecture.